Welcome back, wonderful math students. Now we are going to be setting upon a review of probability over the next couple weeks, and then we're going to be coming back to geometry to wrap up some trigonometry at the end of the course. Now, today we are going to be taking a look back at Venn diagrams, yes, and sets. So a couple things about these symbols. The little U looking symbol stands for union. That means you're going to be looking for any element that's in set A or set B. So if it's in one set or the other, it's part of the party. This little upside down U means intersection. That's any element that is in both sets. So for an element to be part of this party, it has to be on both lists. Let's go ahead and take a look at number 1 to find the intersection of A and B. So number 1, with the A union B, what you're going to do is look for anything in either set. So since I see a 2 in set A, that's going to be part of this new set. Since I see a 5 in set A, it's going to be there as well. Now I'm going to move on to set B. 5 was there again. Don't need to write it a second time. It's already accounted for. I need to include the 7 from set B and the 9. So you look for any element that you're seeing in either set and include it in this new set. Again, no need to duplicate on values, so you're good there. Now I'm going to jump down to number 7, where I'm going to do the intersection of these two sets. So A intersection B. Now, when I'm looking at an intersection, I'm looking specifically at the elements that occur in both sets. So I'm looking at 2 and 5, and I'm looking at 5, 7, and 9. The only element that's in both is 5. So my answer here is simply 5, because this is the word and. It has to be in both sets. I'm looking at a 5. All right, I'm going to jump down to number 10 now to finish up my examples for this group of problems. Now that I'm looking at number 10, what's going to happen is B is the set of values 5, 7, and 9. Now for C, it says, and I'm going to read this out loud, that X such that X is an odd number less than 9. All right, so what I'm going to do is actually just write out those values, what they are. X is an odd value less than 9. So 1, 3, 5, 7, and I'm not going to include 9 because it's not less than 9. It would be equal to 9. Now that I've got those values written out for set C, now this problem's probably going to be a little bit easier. I'm looking for values that are both in set B and set C. So those values would include 5. 5 is present in both sets. So I'm going to go ahead and include a 5 here. 7 is also included in both sets. So it's there. And that was it. 9 was not in both sets. Neither was 1 or 3. So they're left off. That's all you have to do for this group of problems. Hopefully that's making sense. All right, now for the rest of the problems, you're going to use Venn diagrams to describe what's going on here with these populations. So on number 13, we'll go ahead and develop one of 320 students. So that's representing the entire population. So I'm just going to make a big rectangle to represent all 320 students. Now what I'm going to do is take a look at the band and sports teams. So that's going to be my two circles, and there is an overlap here. It actually says that 60 participate in both. So before I even label them, I know that 60 from my instructions is going to be who participate in both. I'm going to make the one on the left the band students. I'm going to make the one on the right the sports team participants. And now I'm going to figure out what goes where. So since 85 students participate in band, I'm going to do 85 minus 60, and that's going to be 25 students who solely participate in band and do not involve themselves with sports team. Now, for the 200 that are on a sports team, I'm going to subtract away 60 from them, that participate in both, and know that 140 students of the 320 participate only on sports teams and don't include themselves on band. Now, you might be noticing that if you add these values up, that would not make for 320 students. That's the reason why I introduced this rectangle to include the two objects. Sometimes it's there, sometimes it is not, but it is in this situation. So what I'm going to do really quick is I'm just going to add all three values together, the 140 that are only on sports team, the 60 that were on both, and the 25 that were only on the band, in the band. So that'd be 225. What that tells me is that there's 225 participating in band or sports, one or the other, maybe both. So that's great and all. But what I'm going to look at here is that tells me that there's 95 students, and that came from doing 320 minus 225. There's 95 students that are participating in neither. Okay, so now that I've got a completed Venn diagram, this becomes really, really easy. For instance, for part A, I'm going to do parts A, F, and G for you. So for part A, how many students are taking band and not on a sports team? Here's my students that are in band and not on a sports team. So that's 25 students. Now for part F, since it's showing the intersection symbol, so B intersection S, so band and sports together, that's actually really easy. That's the students that are on both. So that's actually going to be the 60. That's the intersection. So that's a pretty easy question, even though they're using a symbol. And G, what is the union of band and sports? How many students are on band or sports? Well, that's actually something we already did here. We added the sports only and the band only and the ones that were on both, so 225. And you should be able to answer the rest of the questions using this Venn diagram. So the last thing I'm going to do for you on this video is I'm going to set up number 17 really quick and then leave the rest to y'all. Please let me know if you need help. And there are 30 people in a class. And it's talking about having brothers and sisters. So I'm going to make one of my circles brothers, the others sisters. Now it does say that 5 of them have both, 16 have only brothers, and 4 people have neither a brother nor a sister. We're going to find out how many must have only sisters. To do that, I'd simply take the 30 people that's in the class, and I'm going to subtract away 16 that had only brothers. That leaves me with 14. I'm going to subtract the 5 that had both. That leaves me with 9. And I'm going to subtract away the 4 that had neither. That's going to leave me with 5 that must have had only sisters. So 5 have only sisters. Is my final answer. All right, so definitely the Venn diagram is not required for this. You can also do it in a two-way table. I'm going to avoid doing that on this video just to not make things complicated. All right, folks, I really appreciate it. Let me know if you have any questions on the assignment. You can definitely email me as the preferred way, and then maybe we could do a video conference or something like that if you need more help. All right, bye.